All right, on your sheet of paper, go ahead and write solving logarithmic equations. Solving logarithmic equations. The little half sheet that I gave you is a little flow chart you can work your way through if solving these equations gets confusing for you. So yesterday, when we were looking at the problems did not have the word log or ln in them, right, Anna? They didn't have that in them, no. That meant it was an exponential equation. And so we had two options. If we could change the base, we would use the chart to change the base so we could solve the problem. If we couldn't get the bases to be the same, we would either Tootsie Roll or log both sides, whatever you were comfortable with. Okay? So this side of the flow chart is what we used yesterday. Today we're going to say, is there going to be a log or a natural log in the problem? Yes, because we're solving logarithmic equations. Next, you have to ask yourself the question, is the log on one side or both sides? So maybe you just have a log on the left or just on the right, or you could have a log on both sides. To do the problem, you are only allowed to have one log per side, okay? So I'm going to write that on my little chart here, well, my flow chart. I'm going to say only one log per side. And the way that we get the problem to only have one log per side is we use our property of logarithms to condense the log. So if it's a addition problem, we say that it's one log and the two things have been multiplied together. Do you guys remember doing that a couple days ago? If it's a subtraction problem, it means they're divided. If you have a coefficient in the front, it means that that was an exponent. Okay, so we're going to use those properties to condense it down. Then, if the log is only on one side, you can either Tootsie Roll the problem or put a base of the exponent in there. I'll show you guys what I mean in a second. Or if the log is on both sides, then you can just ditch the logs because it's the same thing on both sides. Okay? So as you do these problems, because now on the assignment for today, we're going to have 4 types of problems we can solve. This helps you clarify the process for all 4 of the problems. Make sense how it works? Okay. So keep that off to the side. That might be helpful for you. We'll go ahead and do our first example, which says log base 5 of 2x squared minus log base 5 of 7 equals log base 5 of 56. So if we look through our flow chart, the first question said, is there a log in the problem? What's your answer? Yes. Yes, definitely. Is there a log on one side or both sides? We've got logs on both sides. We are only allowed to have one log on each side. Is that happening in this problem? No. So what do? We got to condense the left side because there's 2 logs on the left side. So I only get to write log base 5 one time. And it's a subtraction problem, so what should I write? Divide. So we have 2x squared divided by 7 equals log base 5 of 56. Yeah?
And you would not be able to do that if they were different bases.
You would not do that if they were different bases. Yeah. Okay. Now, at this point, when we can see that these are both the same, it's kind of like when we had an exponential equation and we made the bases the same. As soon as we had like 2 to an exponent equals 2 to another exponent, we would ditch the 2's. As soon as we have log base 5 of something equals log base 5 of something, we can ditch the log base 5. So that means we just have 2x squared over 7 equals 56. So what should I do now? Multiply by 7, multiply by 7. There is a phone back there. Here. What's 56 multiplied by 7?
392.
392. Okay. What else should we do? Divide by 2. Okay. X squared equals 196 square root x equals, does it just equal 14? Oh, poor dead ducky.
14 squared.
Mark back there, you killed a duck.
Equals 14 squared.
No.
No.
Equals
14.
equals plus or minus 14. Poor dead duck. Oh, poor little ducky. Because to get a square number, you can either multiply two negatives or two positives. So when we undo that, we have to say it was two negatives or two positives that did it. Okay, now there's one thing to watch out for on this. We have that, plus or minus. There is a possibility in these problems of extraneous solutions. Does anyone remember what an extraneous solution is? Extraneous solution.
I've never heard of it.
It's a random number.
You have. Yeah, it's an answer that you find mathematically that does not work. Okay? So if you guys remember, this was back in like the first unit we did. We said that some functions had limited domains. We said that rational functions, those are the fractions, those can't equal 0 on the bottom. We said that we had square root functions, excuse me. And what did we say about square root functions? Do you guys remember?
Equal or greater than 0.
Yeah, greater than or equal to 0, right? So it could equal 0 or a positive. And then we said we have log functions. Anyone remember what those were? They just had to be positive. They just had to be greater than 0. So what we need to do is we need to take these two answers and we need to make sure that when we take the log of something, that something that we are taking the log of has to be a positive number that is greater than 0. Okay? So I'm not saying you have to check every answer, but I am saying that when you get these answers, you just have to make sure that you're not taking the log of something negative. Okay? So if I plug in a positive 14, 2 times positive 14 squared, is that going to be greater than 0?
Yeah.
Yes. What about negative 14? 2 times negative 14 squared.
Yeah.
Yes, because when you square a number, it's always positive. Okay, both of these answers are okay. Neither one of them is extraneous, okay? So I'm going to say x equals positive and negative 14, and I'm done. So on my little flow chart, I'm going to add some notes here. I'm going to say check to make sure you aren't logging a negative. You cannot take the log of a negative number. Now, when we did yesterday's assignment, did we ever check for extraneous solutions?
No.
No. A lot of students yesterday would have been fine, and then today we talk about extraneous solutions, and then all of a sudden they're very confused and they think that every single problem they ever do has an extraneous solution. So we're going to go over here to the side, and we're going to say, do not worry about extraneous solutions. It's extra, E-X-T-R-A, and then N-E-O-U-S, extraneous. So extraneous just means like extra solutions that aren't right, okay? You do not have to worry about extraneous solutions with exponential equations. You can literally plug any number you want into an exponent. You can plug in decimals, negatives, pi, square roots, any number you possibly want can always be plugged into an exponent. You do, however, have to worry about what you plug into a log. It has to be a positive number. Okay? All right. So today we checked for extraneous solutions. Yesterday we did not need to, which is why we didn't. Okay. Let's go ahead and do another example. Have we had enough time to write that stuff down?
Yes.
Yes? Okay. Example 2. All right, we've got log base 6 of x plus 5 plus log base 6 of x plus 4 equals 1. Okay. We are allowed to have 1 log per side.
Can you just subtract the log to the other side?
If you subtract it to the other side, you are not going to like that 1.
Alright.
That's going to be difficult to handle. So it'll be easier easier for us to condense the two logs together than it would be to move it to the other side. So I'm going to write log base 6 one time. And this is an addition problem, so what am I doing? Multiplying. And how do we multiply these together? We FOIL them. Okay, so when I FOIL that, x squared plus 4x plus 5x. So 4x and 5x is 9x plus 20 equals 1. Okay, so we have two options for getting rid of the log. You'll notice this is different from the last problem because the log is only on one side. So I can't say, oh, there's a log on each side. I can just get rid of them. We have to convert this into exponential form. So you can Tootsie Roll. How would you Tootsie Roll? You would say you have a base of 6 to the first power equals
x squared plus 9x plus 8.
Yep. Okay, that's one option. The other option is for those of us who maybe don't think we'd remember to to get rid of it, I Tootsie Roll. So for some people that's hard to remember. So the other way, I'm going to write the same problem, is to think of it as I'm undoing the log by doing the opposite of a log. And we know that the opposite of log form, I put the equal sign in the wrong place. We know that the opposite of log form is exponential form, right? So if the opposite of log form is exponential form, then what you do to solve this problem is you write 6 with all of this as an exponent equals 6 with a 1 as an exponent. So I'm writing the left side and the right side both as exponential form. 6 to this big nasty exponent, 6 to this exponent. All right? And then a base of 6 for an exponential problem and log base of 6 are opposites of each other, so they cancel each other out. And that leaves me with x squared plus 9x plus 20 equals 6 to the 1, which is just 6. Either way of doing the problem is right. You do the way that sounds more memorable to you. The reason that I've started showing this way to students is because I found that students forget Tootsie Roll. They forget it. That's what I noticed. So this might be a little bit easier to remember because you're thinking about the opposite of logarithmic is exponential, instead of just thinking, oh, I Tootsie Roll everything. Okay? All right, so from here, we have a quadratic. It equals 6. Is that a good thing for a quadratic to equal? No, what should it equal? 0. All right, so let's go ahead and subtract the 6 over to the other side. So 0 equals x squared plus 9x plus 14. Okay? How are we going to solve a quadratic that looks like that? Factor. So multiply to 14, add to 9, 7 and 2. So what are my factors? X plus 7, x plus 2. So my two solutions. Okay. And before we say those are good answers, what do? Check to see if you're taking the log of a positive or not. Okay? And whenever we check it, we always go back to the very original problem. So I've got -7 is one of my answers. -7 plus 5 is -2. Can I take the log of -2? No. And then you can see it would have been an issue here as well. -7 plus 4 is negative. Perfect, thanks. Okay, so that's an extraneous solution. And this is how I expect to see extraneous solutions on your paper. I expect to see that you found it, and then you X it out because it doesn't work. Okay? Because we could have gotten the extraneous answer by doing a problem where we square root and you get plus minus the answer. Well, maybe you killed a duck and then the negative version was not an answer anyway, so you think you should get full points, and then I say, no, you needed to know that there was a negative answer there, it just was extraneous. You guys see the difference? I need you to be able to find all the solutions and then tell me which ones do not work. Okay, now for this one, -2 plus 5, is that okay? That's 3. -2 plus 4, 2, that's good. So this is a good answer. Ms. Rice, what happens if they're both extraneous? Then your answer is no solution. Okay? So if it ever happens that the answers do not work, then you would say no solution. You will notice that oftentimes the extraneous answers happen to be negative. That does not mean that every negative answer doesn't work. Okay? So you always check it, because we just noticed that in our 2 examples, we had 2 negative answers that did work. Okay? A lot of students, after they do a whole worksheet, they're just going to start to assume the negative answers do not work, and that is not true. Okay. Any questions? We're good? Okay.